Fundamentals for Engineering, Mathematics, Final Exam Revision, questions 10 and 11. So for question 10, we want to find the possible solutions for the following. So here we see we have our absolute values. Our absolute value of 2, x minus 3 is greater than 5. So we know, well, this could be a negative or it could be a positive, this whole 2x minus 3. We don't know at this point here. So here we say, well, we can take 3. In the positive case, 2x minus 3 is greater than 5. So here we can add 3 and add 3. 2x is therefore greater than 8. Divide by 2, divide by 2. X is therefore greater than 4. In our negative case, there's two ways we can go about it. First, we can look at, well, here if we had negative 2x minus 3 is greater than 5 here. So we get negative 2x plus 3 is greater than 5. And here we need to switch our negative 2x, or what we do, we add 2x and add 2x here. So 3 is greater than 5 plus 2x here. Now we're going to minus that 5 and minus 5 here. So 3 minus 5 gives us negative 2 is greater than 5 minus 5 is nothing, so it's greater than 2x here. And then we can divide by 2 and divide by 2 here, so we end up with x is less than negative 1 there. So we can write that the other way around here, x less than negative 1. So this holds for true, x is greater than 4 and x is less than negative 1. The other method is, instead of doing this second method and moving everything over, we go straight from this stage to two equations where we have 2x minus 3 is greater than 5, and we say, well, here 2x minus 3 is less than negative 5. So our two ways of going about this. So if we look at question 2 here, our absolute value of 5x plus 6, so if we look at our positive case, we've got 5x plus 6 is less than 14. If we follow this through here, we're minus 6 minus 6. 5x is therefore less than 8. We divide by 5, divide by 5. X is less than 8 on 5. For our second case, if we look at our negative, so we have 5x plus 6, and we have a negative out the front here, is less than 14. So minus 5x minus 6 is less than 14. So we can add 5x here. Minus 6 is less than 14 plus 5x. We want 5x by itself, so we're going to minus 14 and minus 14. Minus 6 minus 14 gives us minus 20 is less than 5x. We divide by 5, and we end up with negative 4 is less than x. Or here, we can write up here, x is greater than negative 4. Now looking at question 11, we're going to solve simultaneously. And what we have here, again, we have a couple of different methods that we can use. So we'll just split this here. We're going to say that's equation 1 and equation 2. When we look at these, we've got an x in each, and we've got this 5y and a 5y in each. So what we can do is equation 1 plus equation 2. And what we do is we add our left-hand sides together. So equation 1 is x plus 5y. Equation 2 is, adding here, so we've got plus. Equation 2 is x minus 5y here. Then we add our right-hand sides. We've got here 34 plus negative 6. So we've got our x plus 5y plus our x minus 5y. On our other side, we've got 34 plus negative 6. So x, and we write it all out, we've got x plus 5y plus x minus 5y is equal to 34 minus 6, will give us 28. So here x plus x gives us 2x. Then we've got plus 5y minus 5y, and these y's cancel out. So here we're going to get, well, 2x is equal to 28. Therefore x divided by 2 x is equal to 14. Then we can come back to one of our equations here. We might put it in equation 1. We've got x plus 5y equals 34. So 14 plus 5y equals 34. We're going to minus 14 and minus 14. 5y is equal to 20. Divide by 5, divide by 5. Here y is equal to 4. So we have x is 14 and y is equal to 4. The other method that we can use is to rearrange one of our equations, and 2 would be simpler to rearrange. So here we've got for equation 2, x minus 5y is equal to negative 6. So we add 5y and add 5y. We end up with x is equal to 5y minus 6. Then we substitute this into our equation for 1, which is x plus 5y equals 34. So instead of our, that's an x, instead of our x, with this part we write this part here. So 5y minus 6 plus 5y is equal to 34. 5y plus 5y is 10y minus 6 equals 34, and we add 6 and add 6. 10y is equal to 40. Divide 10, y is equal to 4. So this is the same as what we had here. And then we substitute back into our equation up here. X is equal to 5y minus 6 is 5 times 4 minus 6, so it's 20 minus 6 is 14, which is what we got here before. So similarly for question 2, we can rearrange and make one of these y is equal to something and then substitute into the other. Or what we can do is say this is plus y and plus y. If we did equation 1 minus equation 2, we'd get plus y minus y. So if we look at equation 1, we've got minus 4x plus y minus, and we look at this part here in equation 2, 3x plus y. Here equation 1, negative 2, and we're minusing equation 2, so minus 5 here. So here we've got minus 4y plus y, and here minus 4x plus y, minus 3x, and then here minus y. Minus 2 minus 5 gives us minus 7. So minus 4x minus 3x gives us minus 7x. Plus y minus y cancel each other out, so we get minus 7. If we divide both sides by negative 7, we're going to get x is equal to 1. And we substitute into one of our equations above. We're going to get here, second one looks easier, so we're going to say, well, 3x, 3 times 1 plus y is equal to 5. So 3 plus y is 5. We're going to minus 3 minus 3. Y is equal to 5 minus 3 is 2. And for our other method, we'll just go through really quickly. We could rearrange, say, equation 1. And we'd make equation 1, we're going to plus 4x on both sides. So y is equal to 4x minus 2. Then we substitute this into 2. 3x plus, and instead of y, we write this 4x minus 2 in, is equal to 5. So 3x plus 4x is 7x. Minus 2 is equal to 5. We add 2 and add 2. 7x is equal to 7. Divide 7, x is equal to 1, which is what we had here. And then we substitute this into any of our equations above. We might substitute it into equation 1 or equation 2, but it's the same thing. We've got this x is equal to 1. So 3 times 1 plus y is equal to 5, and we're going to end up with y is equal to 2.